Well, welcome to another geometry video. We are in section 11-1, and we're going to be talking about 3D solids and just a quick introduction for it. So by the end of this video, I'd like for you to be able to identify the types of 3D solids as well as their individual parts. And then also, ideally, you'll be able to visualize cross sections and nets of 3D solids. So to begin with, we need to define a few of the types of solids that we have. The first type is a prism. So a prism is formed by two parallel and congruent faces called bases connected by faces that are parallelograms. So this right here is an example of a prism. That's a triangular prism. We also have something called a cylinder, and a cylinder is formed by two parallel congruent circular bases with a curved surface around them. And then this is an example of your cylinder. We also have something called a pyramid. Now, a pyramid is only going to have one base, and then its faces are going to be triangles, and they meet at a common point or a common vertex. So this is an example of a pyramid, and then the singular point up here is that vertex. And then another basic type of 3D solid we have is a cone. A cone is formed by a circular base and a curved surface that connects the base to a vertex again. So here's the picture example of a cone. So what we're going to do is identify some of the parts of a 3D solid in our next example. So in example 1, it says, classify the figure, name the vertices, edges, and bases. So first of all, we just want to look at this image and say, okay, what type of 3D solid is this? Notice that it is made up of all parallelograms, so it cannot be a cone or a cylinder, but also all of its points don't meet at a single vertex like a pyramid does. So we now know this is a prism. So what type of figure is it? It is a prism. Now the vertices of any 3D solid are kind of like the corners or the points of the edges where they meet. So vertices are points of the corners, basically. Now, if we are to name these from this prism right here, we need to name all of the corners, and we're going to name them by the point that is at it. So this would be point A, point B, point C. So all we have to do is say points A, comma B, and we're using capital letters because we were naming these points. We're going to go through all of them. So C, D, E, F, G, and H. It's going to be all of those. So A, B, C, D, E, F, G, and H. So it has 8 corners, and that makes sense. So we have 8 letters listed here for each of those points. We also want to name the edges. Now, an edge of a prism is literally going to be a segment, and it's going to go from vertex to vertex, or vertice from vertice. So segment AB would be considered an edge. So these are segments, just so you're aware, and we're going to name that. Now, it's been a while since we've named things in geometry, but to name segment AB, you put the 2 endpoints and then a straight line above it, no arrows or anything on top of it, just segment AB. Now we're going to name all of the edges. So we have segment AB, and it might be a little tough to keep track of everything. So if we look at the top of this, kind of like a square or something like that, I'm going to name all of the edges for the top of the shape. So we got AB, BC, CD, and AD. So I'm going to name all 4 of those. So I've got AB, BC, CD, and DA. Okay, then I'm going to go through and I'm going to name all of the vertical edges just so I don't miss anything. So AE, BF, CG, and DH. So I'm doing all of those 4 now. So I've got segment AE, segment BF, segment CG, and segment DH. Okay, and then I need to go through and do all of the edges at the bottom of the prism as well. So from here to here, and all of these sides. So we're gonna have 4 more edges. So edge FE or EF, we could name it both ways. The order of the letters does not matter. We have FG, GH, and HE. All right. So that is 12 edges, and that makes sense because we've got 4 at the top, plus 4 more going up and down, plus 4 more along the bottom. So those are our 12 edges. And remember, those are line segments. Finally, we're going to name the bases. Now, in order to name a base, that we're actually naming a plane. You can do this in more than one way, and technically we could move this shape on any side and it would be a new base just because of the type of prism that it is, but I'm just going to name 2. So we've got base ABC up top. You just have to name 3 points in order for it to be named. And then we've got EFG as well. All right. Now you could also call this like parallelogram ABCD, or you could call it parallelogram EFGH as well. Okay, so that's our first example. Flipping our paper over, now we have some 3-dimensional solids described in kind of a 2-dimensional way. If we were to think of these shapes as being pieces of paper and that we could fold up or unfold or something like that, it would form something called a net. So in example 2, we're going to describe the 3-dimensional figure that can be made from the given net. So if we were to cut this out and then fold it along all of these lines, what shape would this end up making? Well, if we were to fold that up, that would end up making a cube. So we're just gonna write cube underneath of it. Here we have one circle and then this half circle right here. So if we were to take this half circle up and then reconnect it here and kind of curl it around that circle, this would not form a cylinder because it does not have 2 bases. It would form a cone because it only has 1 base. And then finally, if we were to take this last shape and fold along these edges or along those lines, what would it form? It would form a triangular pyramid. All right, so those are nets, and a net is basically an unfolded version of a 3D solid. The last type of examples that we're going to be working with are examples 3 and 4, and they talk about cross sections. So cross sections are going to be the shape that's formed when you cut through a solid, basically. That's essentially what's going on, the shape that's formed when you cut through a solid. So here, what we are asking is, what new face would be formed? So here in this first example, we have a plane cutting through this pyramid. And so now we're asking ourselves, what would this shape be right here, that part? So notice it has 5 sides. It would be a pentagon. The ink is a little unclear in this next one, but we've got this prism and we're taking a plane and cutting through it, and we're asking ourselves, what basically would this face form? So we're kind of like a knife cutting through a loaf of bread. What is this new face going to look like of that slice? That is going to be a hexagon. And then finally, in our last example, we have a cone and we're having a plane slice straight from the top to the bottom. And it's cutting this section right here. Now, it does form two half cones, absolutely. But what we're asking is, what will the face of that slice look like, okay? What's the polygon going to be? Well, this is going to be a triangle. Now, sometimes you have the plane drawn through the 3D solid and all you're doing is identifying the cross section. Sometimes you're told you want to form a type of cross section by drawing in a plane yourself. So that's actually this last type of example. It says, how could you cut through each given solid to form the given cross section? Draw on a plane to show your answer. So how could we cut this cone in order to form a circle? Now, there's more than one answer based off of how high up you draw your plane, but this is my example. So if I were to take a plane and cut through it just like this, then that plane would end up cutting a circle like that. So that's one example, but it needs to be parallel to the base. So I'm actually gonna label that parallel to the base, just so you can see that. Okay, and then in the next example, we're being asked, how could we take basically a knife or a plane, cut through this shape to form a triangle this time. Now, once again, there is more than one way, but something that we could do is focus in on kind of a corner of the box. And if we were to take a plane and make it cut through kind of at this angle to where it's only cutting off this corner, notice where it's kind of like cutting off a pyramid off of the shape. Well, once you take that off, here we have a triangle. Now, there is more than one solution to both of these based off of how high up or how low you draw your plane, but this is just one example of how we could get these solutions that we're looking for. So that's it for section 11-1. I hope that this has been helpful, and of course, bring any questions you have to me in class time. Have a good night.